Good morning, seventh graders, and happy Freya's Day. Last day of our first full week of online school. I hope you're doing well, your family's doing well, and you're taking care of each other. L82, we're going to look at a new idea, multiplying numbers in scientific notation. It wasn't too long ago that we had a lesson about making sure that things were in scientific notation. So just as a quick review, here are two things in scientific notation. Remember, things we want to be concerned with are what we call the first factor. That's that 3.25 and that 2.193. Remember, those have to be in this range of greater than or equal to 1 and less than 10. That's just a standard. Now, it is pretty standard across the world that everyone uses the x for multiplication. However, Saxon sometimes doesn't. It kind of bothers me about them. But always use the x. And then remember, we need an exponential power of 10. And we have that in all of these situations. Obviously, 10 to the fifth and 10 to the negative second. I know you know how to turn these into standard, or at least you're expected to. That's not what today is about. In fact, the most important part of today is that you remember that we keep this stuff in scientific notation. It is purposeless for us to multiply numbers that are formed in scientific notation, such as this 1.2 times 10 to the fifth, and I'm multiplying this by 3 times 10 to the seventh. We do not, under any circumstances, want to turn this into standard notation. Strangely, some of you might, and I'll just wonder, did you listen to the video? Don't do it. In fact, what we're first going to do is we're going to group the first factors together and our powers of 10. So that would look like this, 1.2 times 3, and then I'll group together my powers of 10. 10 to the fifth times 10 to the seventh. Now, obviously, if I can't figure out what 1.2 times 3 is in my head, I'll come off to the side here, 1.2 times 3, 3.6, right? I know I'm saying them wrong. It's just visually, I think it's easier to say 3.6 for you. So once I've done that, now you got to think about, well, what's going on in this? This is actually one of our exponential rules. It's multiplying powers with like bases. Do you remember what you're supposed to do in that situation when you multiply powers with like bases? I hope you do. In fact, I'm going to digitally send you the reference sheet so that we can always have that with us. But we add the exponent. So 10 to the fifth times 10 to the seventh would simply be 10 to the 12th. Now, we're going to see another problem later that we're going to have to do more. We're going to have to adjust. But one thing I should always consider is my first factor in that appropriate range. And in this case, 3.6 is, so I can box that up. Let's do another. Here I have 4 times 10 to the 6th times 3 times 10 to the 5th. Remember, we are not turning this into standard notation. We're going to keep everything scientific. We're going to group first. We'll group our first factors at 4 times 3. And then we'll group our powers of 10 at 10 to the 6th times 10 to the 5th. And then 4 times 3, clearly 12. Oh, that's what I was talking about. Okay, so, and then we should, this is multiplying powers with like bases. Let's add those exponents, giving us 10 to the 11th, right? Now, here's the thing, and please, you may need to adjust. So always look at that first factor, because if that first factor isn't in the appropriate range, then we're kind of in trouble. So what we're going to do is we're going to move the decimal point. So obviously we know the decimal point exists to the right of the 2. So if I move it that way, I'll end up with 1.2. Now here's an important question, because the whole thing is we have to think about, did I just decrease or increase my first factor? So I was at 12, I made it 1.2. I think we'd all admit that that's a decrease. And here's the key. We're creating equal things. This first thing's equal to this thing, which is equal to this. So I have to keep it balanced. And if I decrease that first factor, what do you think I have to do to my power of 10? Yeah, in order to keep it balanced, I must increase it. And because I moved that decimal place just once, I have to increase by 1 on my power of 10. So instead of 10 to the 11th, I have to make it 10 to the 12th. And then I can box that up. Yeah? So be careful there. Your first factor must be in the appropriate range. Let's do just one more. Make sure that we're on tap here. So we have 5 times 10 to the third, 7 times 10 times 7 times 10 to the negative 6. Again, no standard notation. Let's do our grouping. We'll group together the 5 and the 7. We know, oh, we are already thinking ahead, I hope, and going, oh, we're going to have to adjust. Yes, you will. And then we have 10 to the third times 10 to the negative 6. So clearly 5 times 7 is our 35. And then this 10 times third, remember, it's still multiplying powers to third bases. I still add those exponents. I should be asking myself battle questions. Is it a battle? Yes. Who's going to win? The negatives. By how much? Negative 3. So I'd say 10 times negative 3. Now, should I adjust? Yeah, because 35 is way too much. So if I adjust it to 3.5, did I increase or decrease? I decreased, right? So I have to increase my power of 10. But be careful here, because when I increase that power of 10 in negative land, it's going to look a little different, because 10 to the negative third increased by 1 will actually be, 10 to the negative second. Yeah, and then that's it. So, look, a really quick video. I don't know if I was speaking quickly or this is just kind of a quick idea. Important things. No standard notation. We're not turning these into regular numbers. We keep everything in scientific. We use the appropriate symbols, such as the X. Even if your book doesn't, please do. And most importantly, probably is that adjustment period and being careful about negative land and asking yourself battle questions. Yeah. So kind of a quick one today. It's a phrase day, so that's nice. We'll be assigning the split on Monday, and I hope you're well. Take care. Bye.